In this video we will look at complex numbers, a topic from further mathematics. A complex number always has a certain form. In words we say a complex number equals a plus bi. Here a and b are real numbers. The letter a is called the real part of the complex number. The letter b is called the imaginary part. It is important to know that the imaginary part is just the plain number b, not b times I. There is one special rule that makes all of this work. In words, I squared equals -1. Before we solve our example, let us look at the shape behind it. If we draw the graph of y equals x squared plus 2x plus 3 in 2 dimensions, the curve stays above the x-axis and never crosses it. This is our first clue that the equation z squared plus 2z plus 3 equals 0 will not have real solutions. Now let us look at the same idea from a 3-dimensional view. Imagine rotating that same curve around its lowest point, so the 2-dimensional parabola sweeps out a 3-dimensional bowl shape called a paraboloid. This helps us see why the missing real roots must instead appear as a pair of complex numbers reflected symmetrically once we plot them. Now we solve the worked example. We want to solve z squared plus 2z plus 3 equals 0. We will use the quadratic formula, one step per line. In words, the quadratic formula says z equals -b plus or minus the square root of b squared minus 4ac all divided by 2a. For our equation a equals 1, b equals 2, and c equals 3. Substituting these values in, z equals -2 plus or minus the square root of 2 squared minus 4 times 1 times 3 all divided by 2 times 1. Inside the square root we get 4 minus 12, which equals -8. Since we have a negative number under the square root, we pull out -1 as I. So the square root of -8 becomes I times the square root of 8. The square root of 8 simplifies to 2 times the square root of 2. So z equals -2 plus or minus 2, I times the square root of 2 all divided by 2. Dividing every term by 2, we get our two roots. The first root is -1 plus I times the square root of 2. The second root is -1 minus I times the square root of 2. Notice that these two roots are a conjugate pair, since they have the same real part, -1, and opposite imaginary parts. Now for the check step. If we add the two roots together, the imaginary parts cancel out, leaving -1 plus -1, which equals -2. This matches the original equation, since the coefficient of z was 2, confirming our two roots are correct.